I am going to keep this in this display. It's not quite as big as the other one, but I want to be able to change pin colors on here. And I don't know how to do that without excuse me, keep it in this view. All right. So chapter 5 or unit 5 focuses on the electron. And honestly, that's what we're going to be focusing on pretty much for the rest of the year, because it's these electrons and how they rearrange themselves and bond that determine the reactions that occur. Okay, so that's kind of where our focus is going to be on for the rest of the year. But we need to kind of understand how that works. So we're going to talk about light and waves today. The first thing we need to talk about, since you guys don't take physical science typically before this course now, is something called a longitudinal wave. So a longitudinal wave compresses a medium. Okay, and then you have the ability to be able to either feel that or hear it. Okay, sound waves are longitudinal waves. So when I'm speaking to you, I'm compressing the air some, and then your eardrum picks up on that vibration and is able to translate it into your brain to give you sound. Okay, you can also feel these. So if you're sitting next to a car that has a really loud bass, your whole body's like vibrating. This longitudinal wave is also how earthquakes work. Because essentially what an earthquake, once the earth fractures, it creates one of these longitudinal waves, and then that just gets magnified through the solid ground. Okay, and that's why as you move out from the epicenter of that earthquake, it gets less violent. Okay, so those are longitudinal waves. They have to have something called a medium. So for example, if you're in outer space where there is no air, you can't have sound. There is no sound in outer space. So when you watch your Star Wars and pew, 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 you would never be able to hear that because it doesn't exist in outer space, despite what Star Wars and other things want you to believe. Okay. Water, if you've ever been underwater, you can still hear sounds, but they sound different. That's because the sound waves are going through a different medium than your ears are picking up on. If you change even air, your sound will get different. That's why people who like inhale helium and then talk, their sound is getting transmitted through that helium, that different medium. And so that's why their voice sounds different. That's all we're going to say about longitudinal waves for now. We're going to go over to transverse waves. Transverse waves do not need a medium. And we need to be thankful for that because light is one of them. If they needed a medium, then the light from the sun would never reach the earth. Okay? So it's a good thing. There are lots of different types of transverse waves, and we'll talk about those coming up. This is what's called the electromagnetic spectrum. When you see one of these, you kind of need to look at it really closely because this one, radio waves are here and gamma waves are here. But I'm going to pull up my AP notes from a couple days ago. Same company that I got the notes from. Look and see what way they've got it arranged. See? They've got gamma over here and radio over there. So depending on which graphic you end up with, you need to kind of look at it and see which way it's oriented because they'll flip that x-axis on you. Okay. Let's get back to yours. And I warned my AP kids of that too. I pulled up yours and kind of showed them the difference between because depending on, you just got to pay attention to it. But if you look, they always have either values up here or they will have a drawing like this. So you can see that when we're dealing with radio waves, they're really long, okay? They're 1,000 meters long because 10 to the third is 1,000 meters. Yeah, it's meters. Yeah. So they're really long. Okay. So imagine 1,000 meters. That's a kilometer. It's like half a mile. Those are really long. They're carrying energy to you. Okay. These don't hit you very often, very hard. When you get to microwaves, they're hitting you a little more often. This is what your microwave oven uses. They just magnify it. That's what the oven part does. That's why they have a little screen on there, because they're blocking out the waves, keeping them from getting to you. Your cell phones transmit with microwaves. Infrared is heat. Visible light then falls here. So we're getting, the wave is coming more often now, more frequently. When we get from UV and up, that is where you can have damage done to your body if you're exposed to too many. Okay. Too many UV rays can result immediately in, what do you feel the immediate effects of that? Maybe a few hours later? Sunburn, right. What about a few years later? 20 years? Cancer. Okay. So you've got to be careful with those. They're going to change the way the atoms kind of come together, and that's what the cancer effects will work with. X-rays are even worse. Okay. Now, we can be exposed to some of these. Our bodies can handle some of them, but just not a lot. They can handle more UV than X-rays and more X-rays than gamma rays. But right now, just the bricks in the wall, the ground, all of that is emitting gamma rays. Very, very small amounts. Very small amounts. Like, don't get like, oh, I'm going to die. No, you'll be fine. But again, you have to kind of watch your exposure to it. Okay? The electromagnetic spectrum is a type of wave. It's made up of packets. Those packets are called photons. I would highlight, if you highlight your notes, I would highlight that term. You're going to want to know what that is. I'm 99% sure that that is a question on your test. All right, waves, different parts of the wave. So first of all, a wavelength is going to be from two corresponding parts on different waves. So you could do the tops or you could do the bottoms. It doesn't matter. Sometimes they even do the origins here to here. Okay, so, but that's what a wavelength is. As you move up through that electromagnetic spectrum, these are going to get closer and closer together. So your wavelengths are going to get smaller, which means that the wave is going to hit you more frequently. And essentially, every time that wave hits you, it's putting in energy. So the radio waves are hitting you like, okay, you move up to light waves and they're hitting you like this. You move up to gamma waves and that's too much for your body to handle, too much energy for your body to deal with. Okay, that's why those things, UV and up, are a problem. In addition to the wavelength, we have other parts of the wave. The tops of the waves are called crests. The bottoms are called troughs. A trough is like an animal drinks out of a trough for their water. So that's where they got that terminology. Okay. The distance from the top of the wave to the bottom of the wave is called amplitude. And this is how, you know how radio stations in the car, you have an AM band and an FM band. Have you heard of that before? Okay. So the difference between like an AM station is the difference in amplitude. So for example, one radio station might transmit at this amplitude. and another radio station transmits at this. And what your car dial is doing is allowing you to hone in on one of those amplitudes. They keep the frequency the same. And AM stands for amplitude modulation. So to modulate means to change. So that's what your AM station's doing. What do you think FM is? What have we talked about that starts with an F?
Frequency modulation.
Right, frequency modulation. So with that, they're going to keep the amplitudes the same, but they're going to change the frequencies so that you might end up with a, different one that has a different frequency like that. Does that make sense? And that's what that stands for, is frequency modulation. And the Federal Communications, I think it's Commission, the FCC, hands out those licenses and makes sure that, not two places in the same area are transmitting at the same frequency. But, the FM stations don't go very far. So if you are here and you have your presets and then you go down to Florida and you hit the same preset, you're going to get a different station, but it's going to be transmitting on the same frequency. Our walkie-talkies have frequencies that they transmit on. There's different bands within the city that the police use for their things. You can actually get online and listen to a scanner of those, if you know the frequencies for it. You can get online. There's a Broadcastify thing that you can actually listen to the scanner in town. All right. We need to know certain equations and know how to deal with some of these. First of all, we have the letter C here. The letter C is a constant. It stands for the speed of light in a vacuum. So the speed of light in outer space is a constant. That constant is 3 times 10 to the 8th meters per second. All right. This is a Greek symbol lambda. When you write lambda, you just write a line, and then it looks like kind of an upside down Y. That stands for wavelength. And that needs to be in meters. If it's not in meters, you need to change it to meters. And I'm going to show you how to do that today. E is energy. We measure that in joules. And then this, it looks like a V. It's actually kind of a V with a curved side here. It's a Greek symbol nu, N-U, and that is what we use to represent frequency. Frequency is either hertz or 1/seconds. Our eyes can find colors within the range of about 400 to 700 nanometers. So that's what we're capable of doing. Now, they do have other detection devices to be able to detect, like infrared. So a lot of times military will use infrared because they can pick up on a heat signature. So you'll be able to see the person in the dark, but you can see their heat signature if you have an infrared visor. Okay. So that's pretty common. Military, fire departments use it to try to find people in burning buildings because there's so much smoke you can't see the people, but you could see their heat signature. They actually use infrared to be able to detect cracks and stuff in a building.
Wouldn't the fire make infrared scanners?
Well, but it's going to show a different signature. So it's going to show really hot, and then this will be a cool body in the middle of that hot.
Okay.
So they can still, it's kind of interesting. I mean, if you think about it, it makes it be able to see things. Police will use this on drones when they're chasing bad guys at night. They'll put it on a drone, or up in a helicopter. They'll have the helicopter hovering up, and they can see bad guys down on the ground, and they can actually chase them. Interesting. All right, you ready for some math? You ready? You ready to get frustrated and lippy? All right. So we are trying to find frequency here. I want to change my color here. Black. I already got that color. Let's do blue for now. Okay. So the first thing I need to do is I need to figure out what equation I'm going to work with. So we're going to go back to this chart here. Let me move down. Yeah. So we're going to go back to this chart and we're going to figure out which of these three equations we're working with. We have wavelength and we need frequency. So are we going to use equation 1, 2, or 3? Do we care anything about energy? No. So we can eliminate 1 or 2 and 3. We are going to use this equation right here this time. Okay? So that equation, there we go. That equation was C equals wavelength times frequency. Okay, I'm going to try to color code everything for you guys. All right. I need to get frequency by itself. What do I do? How do I get this guy right here by himself?
You divide it by
Lambda, okay? Yes. So I'm going to divide this side by lambda, and I'm going to divide this side by lambda. Lambda will cancel, and that's going to leave me with my wavelength equaling C over nu, frequency. So I need to find out what C equals. What does C equal? 600. I did that backwards. Crap. You guys, I'm so sorry. You've got to be sick of me by now. Right? Yeah, I should be solving for nu here. Because they're asking me what the wavelength does.
That's the V one, right?
That's the V, yeah.
I'm lost.
Okay, I'm going to start over, honey. Okay, I'm trying to find out frequency. This is my frequency.
Oh, that's a frequency?
Mm-hmm.
Wait, so what's the other side?
This is wavelength.
Wavelength, okay.
Okay. So I need to divide both sides by wavelength. And then that's going to get frequency by itself. It used to be so much easier when we had different colored pens that I could just pick up. I miss those days. All right, everybody cool with me now? I've reset. We are good. All right. So I am going to put in my value for speed of light. So if I go back to this chart, I see that they're telling me that this is my speed of light. We're going to assume that all of our problems are happening in a vacuum, and that's going to be our speed of light. Even in AP, you will assume that all problems are in a vacuum, and that's your speed of light. Okay. When you get to college and get in upper level courses, they may change that. But for now, we're good. Good.
Wait, I'm a bit confused again. Sorry. What would happen? What would you need to change if everything wasn't happening in a vacuum.
This number would get slower. We'll get less. We'll get smaller because it doesn't travel as fast. It's kind of like you walking through water. You can't go as fast as through air. Light's the same way. All right, so I'm going to go back. I'm going to put in 3.00 times 10 to the 8th. My units are meters per, means the line, second. Now, in the problem here, they gave us our wavelength in nanometers, but our speed of light is in meters. They're not going to cancel out. That's a problem. So you need to convert your nanometers into meters. This is going back to chapter 2 and your best friend, dimensional analysis. Do you remember? Remember? He went away. He's coming back. He keeps coming back all year long. It's like a bad dream, you guys. 633 nanometers. You might want to write off to the side in your notes somewhere that for every 1 times 10 to the 9th nanometers, you have 1 meter. So you're going to need to pull that out of your pocket often. So you need to do this in your calculator right now so you remember how to do it, because it's been a while since you've worked with scientific notation. Remember that EE key most of you had to use? I want everybody in their calculator right now to try this, and I want to make sure that you end up with 6.33 times 10 to the negative 7th meters. If you don't get that number on your calculator, I want you to call me over right now so I can help you. Because that means that you've forgotten how to work it, and I need you to work it because you're going to have a really bad time over the next, that's not it. Well, that's 1 times 10 to the 9. You have to multiply it by, but you're dividing 633 divided by that number.
0.33, correct? Oh yeah, of course, the time combination.
No, clear. Just one. Oh. Okay, so type in 633.
I have it.
Oh, okay. So then do 633. No, not 0.33. 633. Do you see where it says 633 here?
Oh.
Okay, now you're going to divide by that number. You good? You good? You got negative 7?
I got the negative.
Okay, then you did something wrong. That's why I want to make sure we know how to do this. Don't put in that times. Okay, and that's not how you're going to do this anyway. You go 633, and then you go second. No. 633 divide. Okay, and then you're going to go 1 second EE9. Remember how to do that?
Yeah.
There. You good? You got to the negative 7? Back up that decimal and see if it backs up 6 places or 7 places to get between the 6 and the 3. Perfect. Now, if you back that decimal up, you should be backing it up 7 spots to get to there. That's how you tell if you did it right or not. You two all right? Okay. No. So 633. Hit the divide key there. Now you're going to do 1 second EE 9. There you go. Now, if you back up that decimal, you're going to move it 7 times to get to right there. Y'all good? Where's your calculator?
I threw it in my Johnson card, so I'm going to grab one. So I had drive time and it was in the trunk and it fell out.
No, you're going to use this one for in here today, okay? Because if you're getting a graphic one, you need to know how to use it. So 633, divide it, yep, and now you're going to go 1 second, EE, and then type in your 9. There you go. Okay? All right. We good? Everybody good? I came around and saw everybody? All right. So, once we have this in meters, we can put it over in this equation. So, that's going to go down here. 6.33 times 10 to the minus 7 meters. Now we've got to look at units. Anything divided by itself is 1. So right now I have meters divided by meters. So they're going to go away. That is going to leave me with 1 over seconds for my units. So I end up with, how many sig figs should I have for my answer, first of all? What's my measured amount? How many sig figs in my measured amount? 3. I have 3 sig figs here. So I need 3 in my answer. Oh, sig figs are back too, you guys. 4.74 times 10 to the 14th. And my units, notice I've got seconds on the bottom here. So it's going to be 1 over seconds. 1 over seconds equals hertz. 1 over seconds equals 1 hertz. They're the same thing. Have you heard of megahertz? Sometimes they talk about megahertz in terms of phones, microwaves. They'll talk about it in terms of like computer processors, I think.
How do you divide? How did you divide that with a calculator?
The 3, the final answer.
Yeah.
Yeah. Make sure you get this answer in your calculator. So you're going to go 3, second EE 8. Then you're going to hit your divide. And you're going to type in 6.33 second EE -7, not minus, -7. And make sure that you get my answer up there. Yeah, and see that E14 is back there. Okay. Yours came out okay? Yeah, you got your 14 there.
No, that was not right.
So that's the answer. You don't want the answer. So do 3, and then second, EE 8, divide. Now you're going to do your 6.33, second, EE -7 equals.
Okay, that makes sense.
And then don't forget that part right
I don't
there.
have to do it earlier.
Okay? Did you get yours to come out on your calculator?
Yeah, she was rounded.
Yours came out okay?
That's fine.
Yeah, rounded it. Good. Yours came out okay? Did you get yours to come out? Right?
Yeah.
Oh, good. Okay, good. Lennon, you came out okay? Okay. All right. So, questions on that one? All right. This one we're solving for wavelength and they gave us frequency. So, we are now solving for wavelength. So, wavelength is going to equal our speed of light over our frequency. Everybody okay with me rearranging this equation? And then I plugged in my speed of light, which is meters per second. Now, our frequency is given in hertz. But what do we know what hertz are? What do we know about hertz? Right. So if you think of this as 1 over seconds, that's going to work out better for canceling your units because they equal each other. All right, and I'm just going to plug that value in here. So 4.80 times 10 to the 17th.
Oh, there we go.
It's 1 over seconds, though. So where am I going to put that seconds at? Where am I going to write my S at?
Right by the other.
Nope. It's on the opposite line, right? The 1 would belong here because it's 1 over seconds. So the 1 would be down here, and the seconds would go up here. That's why I like to do this in different ink colors so you can see where those units are coming from. Okay? If you've had enough math, then you know that S to the minus 1 means that it just goes on the opposite side. And that's essentially what this is. It's just telling you that S is going to go, your number is going to go on one side and your S goes on the other. This is called an inverse. We'll eventually get there in math. Haley's shaking her head at me. All right, so my seconds will cancel, and that's going to leave me with meters. Does that make sense since we're measuring wavelength?
Mm-hmm.
Yeah. All right. So I want you punching that into your calculator, and I want to make sure that you get the right answer for it. You should end up with 10 to the negative 10 meters. I can't figure out what ink color is less obnoxious. I wish this would let me just change all of these to one, like all be pens, but I can't figure out. I've gone into all kinds of help screens and stuff, and I can't figure it out. I can do colored pencil, but it doesn't show up very well. Maybe I will do colored pencil. Maybe that will work, that purple. That purple might work okay. All right, do this in your calculator. Did anybody not get that answer in their calculator? I want to get called over. Let me help you. We've got the time. Okay, so clear that because you gotta put your 10 to the 8. You gotta have 8 in there. So 3, second EE, 8. So that's your 10 to the 8 right there. Okay? And you hit your divide key. Now you're gonna put in the next one. So 4.8 and your second EE. And then that's gonna be your whatever. I think it's a 17, isn't it? There you go. All right, everybody else okay? You me to walk over and help anybody else? I'm begging you to let me help you. You good? Anything not making sense on here?
Should we like just do the like numbers first and then figure out the like units in like a second part?
I try to keep my units with my numbers.
Okay.
Okay? The problem with trying to figure them out separately is that a lot of times you forget about them. And I'm trying to train you for AP and for physics. If you take AP Physics or AP Chem, which is probably where you're headed after this course, one of those two, okay? They will, if you get the right numeric answer in there, but you leave the unit off, you're done. They won't count it as a correct answer. So
in example 2, like how did you know that you were supposed to divide by speed of light? like the
No, I didn't divide by speed of light.
I mean like the what
The
was in
frequency.
the question, the frequency is in the denominator. Like why is that?
So your equation that you're working with is this,
Okay.
because it has speed of light and it has frequency,
And
and
then
it solves for wavelength.
we rearranged it for lambda,
Yep.
and then that made it so that speed of light, which is c, had to go over
Yep.
wavelength, which would be
No, frequency.
frequency, which would be represented by that, and then you just plugged it in for each.
Yep.
Okay, that makes more sense.
Okay. Here we have an FM radio station. They're broadcasting at 98.5, but it's megahertz. So this is going to be another example of where we're going to have to use our friend dimensional analysis. We've got to get this from megahertz into, what can we use?
Hertz.
Hertz. Okay. So I'm going to start with that, and then I'll get into that equation. Okay. So 98.5, that's megahertz. I need to get rid of megahertz. So is megahertz going to go on the top or the bottom?
Bottom.
The bottom. So I'm going to do megahertz down here, and I'm going to do hertz on the top. And this is probably a conversion factor that you're going to want to write off on the side, highlight, do something with so you can get back to here. For every one of these, I have 1 times 10 to the 6th hertz. That ends up being 9.85 times 10 to the 7th hertz. And they want us to solve for wavelength. So I'm going to go back. I'm going to grab this equation. I am solving for wavelength. So I want to get wavelength by itself. How do I get wavelength by itself? What am I going to do?
Divide by frequency.
Right. I'm going to divide both sides by frequency. Frequency will cancel out on this side. That's going to leave me with wavelength equaling speed of light over frequency. Speed of light stays the same for every problem. And then I'm going to grab the frequency we calculated up here and bring it down. But remember, hertz is actually what? 1 over seconds. So I'm going to replace this with 1 over seconds. Seconds will cancel. That leaves my answer in meters, which makes sense because we're measuring wavelength. And I ended up with 3.05 meters.
Wait. What did I do wrong?
Did you get that?
I got 0.305. How did I do this wrong?
You have 98.5 here. Instead of 9.5.
Is this 98.5?
But we had to change it into, it was 98.5 megahertz. But
Oh, okay. I see. Thank you.
all right. I want you to see for the next one if you can set it up yourself and come up with the right answer. I'm going to put the right answer on the board. And I want to see if you can come up with, oh, wait a minute. I don't have one for energy on there, do I? I said frequency of a wave. Didn't I change yours to frequency of a wave?
Yes.
Okay, so the PowerPoint didn't get changed. So do the next one while I change this. All right. I thought I changed that. I didn't change it on the PowerPoint though. So 4.7. All right. So that's what you should have gotten for your answer.
Oh, yeah, I did something wrong.
Oh, that is it. Okay.
I did something
Wait a
wrong.
minute, down. You're good. So this weekend, I want 5-1 done. If you scan that QR code with your phone, or is there a QR code? Oh, I guess there isn't a QR code. Yeah, there is. Yeah. So if you scan that, it'll take you through a problem with a video, and then check the answer key. I'm hoping I got everything right this time.
Right number, but not the times. 10 to 15.
Yeah, I got 12.
Yeah, you guys you might want to see me